I think the age of the earth is one of the most critical issues in the creation-evolution controversy, though I find a number of my brethren who appear to have compromised on that point, and they usually begin by saying it really doesn't matter that much. And I think they are missing the point entirely. We have a lot of people who come to us with a rock and say, this rock has been dated at 1 billion years. It's a billion-year-old rock. Now, you think the Earth's just thousands of years old. How can you be so ignorant? Well, if the rock is 1 billion years old, then we've got a serious problem trying to say the Earth is young. If the Bible indicates thousands of years, then it would be wrong. I think this is a challenge, and we need to be able to answer that. That doesn't mean we need to become geochronologists or experts, but I think there's a general picture that we can get and be able to present. There are, of course, many scientists who believe that the Earth is billions of years old. But you need to know that that's not the case with all scientists. There are thousands of highly competent scientists who believe that the evidence indicates that it's young, and many would not want you to know about that. There are many, like Russell Humphreys, for example, that we worked with on a number of occasions. He has a PhD in physics from LSU. He was a geophysicist at Sandia National Laboratory for over 30 years. He has well over 100 patents, a nuclear physicist. He is convinced that most, he would say at least 90% of all the indicators of the age of the Earth indicate a young Earth. And in a presentation that I heard him give just recently, he had 12 points that would demonstrate that the evidence is in favor of a young Earth. And these indicators all indicate young. This is not our outline this evening. It well could be. We're going to use a slightly different approach, and we will touch on some of the evidences for a young Earth before we're finished. But I want to begin by helping you to understand where the evolutionist is coming from when he is insisting on the billions of years. This is absolutely critical for his philosophical position. That's illustrated in a statement here by George Wald, a Nobel laureate from Harvard. He's a microbiologist, and he understands the complexity that we were talking about last evening, the information that's involved in the simplest cell, just beyond comprehension. And so he says one has only to contemplate the magnitude of this task to concede that spontaneous generation of a living organism is impossible. As a microbiologist, he sees that. Yet, here we are as a result, I believe, of spontaneous generation. Now, how does he see that it's impossible and then still believe in it? Well, he has a solution. However improbable we regard this event or any of the steps which it involved, given enough time, it will almost certainly happen at least once. This is the solution. Time is, in fact, the hero of the plot. Now, I know enough about time, and I think most of you do, to know that time doesn't help us when we're trying to organize and when we're trying to go uphill. Time runs downhill, doesn't it? You get a new car and it gets brighter and shiny and more powerful, or it deteriorates and goes downhill. Time doesn't help things go uphill. It's just the opposite. But this is his hero. Given so much time, the possible, impossible becomes possible. The possible, probable, the probable, virtually certain. One has only to wait. Time itself performs the miracles. I don't think time has that power. I think it's impotent to do what he's depending on it to do, but it's the Holy Spirit of the evolutionist, the miracle worker. We're all familiar with the fairy tale of the princess that kisses the frog, and boom, here is then the prince that is magically turned into the frog. And we tell that to the kids and smile and understand this is a fairy tale. But this is what's being taught on our university campuses. And that magic kiss is time. You add time to the story and it becomes science. Yes, the amphibian does turn into the human. It just takes more time. And with time, that solves the problem. I don't think time has that magic wand capability. It has the opposite effect that we can demonstrate in the laboratory. I like to ask why questions when we are dealing with scientific issues, and it's a good way to begin in science. And people think the earth is old. They just hear it over and over and over again. Most of them have no idea why. But a good place to begin in the discussion is, why do you think the earth's old? And usually the first response involves the radioactive dating and the dating of the rock. And of course, everybody here understands how the radioactivity tells us how old the rock is, right? Well, scientists don't either. At least a good many of them don't. Many are highly knowledgeable, but most of the ones using the systems have no clue. But let me give you a general overall picture. Radioactive material is not stable in the nucleus of the atom, and so it emits particles, alpha and beta particles, and decays in that process, losing alpha and beta particles, becoming something else in the process. And that's supposed to help us to tell time, something like an hourglass. We have uranium-238 at the top, which begins to lose some of those 238 particles. It decays down through a series of elements and winds up eventually as lead-206 at the bottom. It's lost 32 particles, which become helium, 4 each. 8 atoms of helium are produced when one atom decays down to lead. Now, that'll be on the test. Everybody keep up with that. That allows us to use this formula down at the bottom to tell time. And just looking at the general picture as it would relate to our experience, if this is an hourglass and you are asked to tell how much time has been going on, you could probably reach a reasonable conclusion. Maybe 12 minutes, maybe 15 minutes. And if you could count the grains of sand precisely, you could come up with a pretty precise estimate of how much time has gone on. And that's not the problem in the time-telling mechanism. We can count the grains. We can count the atoms. That's very precise. But what could go wrong with this kind of a time-telling mechanism? Suppose before you were asked how much time has transpired, someone had lowered the base and let out most of the sand that was already there. And obviously that would skew the picture. It might have already mostly been had run down to the bottom when now it looks like not much has. Or suppose someone had lifted the lid at the top, added a lot of extra sand, most of it had already run down, now then more is added. That would completely skew the calculations. Or suppose just before you were asked, it was laying on its side virtually like this, and they stand it up and they say, now how long? And it had been 12 seconds, and you say 12 minutes. You have to know that it's a closed system, that nothing leaks in, nothing leaks out, and you have to know the beginning conditions for this to be able to tell time, and that is where the problem is in the radiometric dating systems. Henry Fall, who is chairman of the Department of Geology, University of Pennsylvania, a very representative geochronologist, says there are two important assumptions implicit in this equation, the one that we saw down at the bottom of the hourglass. Two important assumptions. First, that we're dealing with a closed system. Nothing leaked in, nothing leaked out. Second, that no atoms of the daughter, that's what's down at the bottom, what's produced, were present in the system when it formed. Now, lead occurs naturally as well as radiogenically, and so it's a matter of guessing how much was there to start with. And if you guess at any step along the line, you might as well guess at the answer to start with. We know how they guess. But these are assumptions that are obvious difficulties. These assumptions furnish the most serious limitations on the accumulation clock. And then he adds, rigorously closed systems probably do not exist in nature. We know water percolates down through rocks, leaches material out, adds other material. You begin with calcium carbonate in the seashell, and that material is leached out. Other material is added, and over time it is fossilized, and seashells can actually become metal, pyrite, as a result of being fossilized. That's leaching and adding that's going on constantly. And we're talking about a process over billions of years, so there's a lot of that going on. But if your hourglass is not a closed system, you can't tell time. Rigorously closed systems don't exist. But surprisingly, many minerals and rocks satisfy the requirement well enough to be useful for nuclear age determination. The problem is one of judicious geologic selection. So this is not just an objective process. It's judicially selecting. If it doesn't come out right, they chuck it. If it does, we select it. And if you're not getting the right answer, you just keep going until you finally find one. Now, if that sounds brash and maybe prejudiced, let me give an illustration from the evolutionists themselves who describe how this process works. Roger Lewins, editor of Research News Science magazine, his good friend Louis Leakey found the 1470 skull, a very significant skull that we'll mention again Thursday evening. It's important, though, only if we got the right date and know that it's what they claim it is by the date. He says in his book, Bones of Contention, the calculated age was quickly refined to be 2.61 plus or minus 0.26 million years, which to anthropologists unfamiliar with the procedures of radiometric dating, anthropologists don't know how it works either, has a comforting ring of precision about it. It sounds very, very precise, as stated here. But he says that's an illusion and goes on to tell us why. He says there were 41 separate age determinations. So this monkey got around. A lot of dating going on. 41 dates, which varied between 223 million and 0.91 million years. Now, that's a huge range, 223 to less than 1. That's just all over the place in these 40 dates. And after the first determination, they never again got 2.61, but that's what they published and didn't mention the others because this is what they wanted. Now, I don't think that's completely honest. It's judiciously selecting the one you want and chucking 41. Does that sound like good science to you? It's a game they're playing to confirm the conclusion that they had to start with. Now, one of the problems is we have difficulty in knowing how to test this because we don't have a reference beginning point, but sometimes we do. Like with the caldera in the center here of Mount St. Helens, here's an eruption, we know the date. Of course, Mount St. Helens 1980, but then the caldera in the center was known to have erupted in 86. This material, this still the dike in the center. We took 5 samples from that dial base sill in the middle in 1997. Now that's 11 years after it was formed, and sent it to the UCLA potassium-argon dating lab. Now, the idea with potassium-argon is that the potassium is decaying, argon is produced as a byproduct, and you measure that. But all the argon would escape while it's lava, while it's flowing. And so that would reset the clock. And so when it hardens again, that starts from zero and then begins to accumulate the argon. Well, that would tell time certainly if you set it at zero, but all of the dates here came back in millions, from just almost 500,000 to almost 3 million for a rock that was 11 years old. So obviously it didn't reset the clock. It didn't go back to zero. This is not a dependable mechanism. And so you go back and you do it again and again and again and again until you get what you're looking for. I don't think that's good science. Maybe the process that we hear the most about is radiocarbon. And in the different processes they use to date different things because they assume it's older, and so we use this one, which is going to give us an older age. This is one that will give us a younger age. It only covers up to maybe 50, 60,000 years. It would all be gone, undetectable, in less than 100,000, which is relatively insignificant in the overall picture of evolution, but very significant for Bible believers who believe the earth's 7,000 years old. But it would all be gone in 100,000. Well, we won't try to tell you exactly how it works. We be glad to try to respond to questions if you have. But notice the statement by Robert Lee, the Anthropological Journal of Canada. He says it should be no surprise then that fully half of the dates are rejected. Now that's, I think, a gross understatement, but he acknowledges, yeah, we toss half of them. The wonder is, surely, that the remaining half come out to be accepted. I would agree with that statement. There are gross discrepancies. The chronology is uneven and relative. The accepted dates are actually selected dates. Now, from the practical standpoint in Israel, I work with a lot of archaeologists over there. They do use carbon-14 reluctantly. They don't like it. They have cultural dating from the style of the pottery, and they're schooled in that for years. And they'll do the radiocarbon, but if it doesn't work, they toss it. And they'll tell you that. If it confirms what they, quote, know already, then they'll publish it. And that's the practical way that it works, and most archaeologists would acknowledge that. They're selecting what they have already chosen to be the date. The RAPE project was, I think, one of the most important scientific experiments done recently. I may be prejudiced about that, but I think it's very significant. It was done by a number of highly qualified creation scientists. John Baumgartner, PhD in geophysics and space physics from UCLA. He was a staff scientist at Los Alamos National Laboratory. And then we mentioned Russell Humphreys, nuclear physicist from Sandia National Laboratory, and Stephen Austin, PhD in geology from Penn State, and then Andrew Snelling, PhD from University of Sydney. These are very highly qualified scientists that are convinced that the evidence supports a young Earth by the evidence that they've examined. But they had proposed a test, and the test involved a number of things with carbon dating. They wanted to date dinosaur bones and diamonds. Now, the geologist who is trained and follows normal procedures will immediately say, this is crazy. It's all going to be gone in 100,000 years. Dinosaurs are at least 65 million years old. Diamonds are billions of years old. There would be no carbon-14. Well, let's just try it and see, which they don't do. They don't ask the question. We did date them with carbon-14. They should have no carbon-14 in them. And yet all of the samples, over 100 dinosaur bones, had significant amounts of carbon-14 in them, which they acknowledge would all be gone in less than 100,000 years, and that they're talking about 100 million years. That upset a lot of people, as you can imagine. That's not what they predict, it's what we would predict. A very important part of the RATE project involved dating coal. Again, you don't date coal with carbon-14 because it's millions of years old, and carbon-14 only covers tens of thousands of years. And of course, one of the objections that they always bring up if a creationist is doing this, no matter how qualified, how much he's done in science, if it's a creationist in collecting samples and dating, well, he contaminated it. He didn't do a good job collecting the samples. So we totally sidestep that claim by using coal samples that were collected by the U.S. Department of Energy and then were maintained in refrigerated conditions at Penn State University. We let them collect and we let them provide the samples. They were collected from all across the country. They were from all up and down the geologic column, from the Eocene, supposed to be 50 million, all the way to the Pennsylvanian, supposed to be 300 million. Dated with carbon-14, which will all be gone in 100,000. Well, this is going to be interesting. How's that going to come out? It all came out about the same, which is certainly not what they expected. All of it had significant amounts of carbon-14 in them, which should not have been there. Now, I think there are dramatic changes in the ratios of carbon-14 that were caused by the flood, and that these are not actual years, they're radiocarbon years, and actually just what we predict. The things that died before the flood would have less carbon-14 in them in proportion to carbon-12, which is what's being measured as predicted. When we date dinosaur bones, these are the dates that we get. When we come back with wood from the ark, hopefully later this year, this is what we would predict, and we publish this is what we expect. But certainly not the hundreds of thousands or millions of years. But there's no difference between the Eocene and the Pennsylvanian. Should be 6 times as much. No, it's the same from top to bottom. I think this demonstrates the fact that with radiocarbon, now then, we're getting thousands, not billions, which is the creationist friend. This is precisely the date that we predict, the results of the process that we would predict, and we're just grinning from ear to ear with this kind of, I think, very significant experimentation. Scientists, creation scientists are doing really good work. But summarizing then with these absolute radiometric dating systems, there are assumptions that they don't tell you about. You don't pick up the rock, it doesn't have date stamped on it. And you don't directly date the rock. You measure sample activities and through a series of assumptions reach a conclusion about the age. The assumptions involve closed system, and we know that doesn't happen, virtually never in nature. We don't know the beginning conditions. You have to assume that, and they don't tell you they're assuming that. And you have to assume that the rate is constant. If that hourglass had the orifice in the center getting large and small, back and forth, letting it go fast and slow, then you wouldn't know what time is going on, how to measure time. And we have good indications that the rate has varied dramatically. And if you have questions about that, we'll go into that in the question period. We see that known ages, like with Mount St. Helens rock, contradicts, and that the old things, really old, are not old, according to radiocarbon. And so because of these reasons, now I think Genesis is a good reason, but that's not what we're talking about here. Because of science, scientific evidence, we object. We say this is not a good reason to be convinced that the earth is old, certainly not with a conclusion that would overthrow faith in the Bible. this doesn't justify that kind of confidence for scientific reasons that we can demonstrate. W.D. Stanfield, who is that vicious anti-creationist that we quoted earlier, wrote a book talking about this. Now, he uses the radiometric dating systems, but he admits there's some serious problems and is relatively objective about what he acknowledges to be the problems. He says it's obvious that radiometric technique may not be the absolute dating methods they're claimed to be. Age estimates on a given geologic stratum by different radiometric methods are often quite different, sometimes by hundreds of millions of years. Sometimes the same rock, hundreds of millions of years different with different methods. And so he says there is no absolutely reliable long-term radiological clock, and he's not got an axe to grind to reach that conclusion. It's in the opposite direction. This is the antagonistic witness who acknowledges. So, when we see these problems even acknowledged by the anti-creationist, we go back to our why question. Now, why? Because that first response is not really scientifically sound. The next response usually involves the geologic phenomenon. And we're told it looks old. You look at the layers, you look at the fossils and the oil and the coal, all of this takes millions of years, and so the earth geologically looks old. And I disagree. I don't think it looks old. I think it looks flooded. And I think that's a better explanation for these phenomena, and we can demonstrate that, and that's where we're going to spend the majority of our time tonight. Many times the implication is acknowledged. Notice here from the New York Times, signs of a great flood. And what they mention in the article are all of these horizontal layers, which is what happens when water lays down sediment. Signs of a great flood, except here they're talking about Mars, amazingly, where there is no water, or at least not now. With each new color photograph from the Mars Pathfinder, scientists are recognizing the awesome magnitude of a deluge that swept over much of the red planet, a catastrophe that perhaps only Noah could appreciate. Well, when you see layers like this, they acknowledge, yeah, that looks like a flood. But when they see the same thing on Earth, they're philosophically opposed to that, even though the Earth is 70% covered by water and there's none on Mars. They refuse to see a flood, in spite of looking at the same thing even more obviously here on Earth. They avoid the implications of the flood by seeing millions of years. And if you don't have the millions of years, then they're faced with another explanation, obviously. But these layers take millions of years, we're told, not on Mars, but here on Earth. How do they come up with the idea of the age of these layers? Well, I can crudely illustrate it by saying, all right, here's a section that's 1,000 feet of rock. And the assumption is, they believe, this is 1,000 years old. Okay, if that's the case, then you divide one into the other. It's 1 foot per 1,000 years, right? Now, nobody's sat around for 1,000 years and saw it, but you assume how much time is involved, you divide it into the number of feet of rocks, and you've got the rate of formation. Not by observing or measuring formation, but by beginning with the conclusion. And then, unfortunately, they turn around and use that to prove the point. This is exactly how the sedimentation rates are reached. Schuster reached the conclusion back in 1931 regarding the rates that are still in most, if at least many, of the textbooks on stratigraphy. The Paleozoic, which would be the major part of the fossil record, is almost 1 foot in 3,000 years. Now that's rather slow, as we have increased estimates about how much time is involved since 1931, but it's still repeated in the textbooks. Now, where did that come from? Did they watch this for 2,700 years? No. They assumed the age, divided that into the feet of rock they saw. More recently, Officer and Drake, writing about the great dinosaur controversy, said a rate of 1 centimeter per 1,000 years is typical. Now that's 1 foot in 30,000 years, which is much, much slower. Schuchert said 1 foot in 3,000 years. Now both of them sound very precise, but 1 foot in 30,000 years is very different from 1 foot in 3,000 years. But where did that come from? Nobody measured it, watched it form. It is beginning with the assumption. Well, many assume that if you look at the rock, you know that there's lots of time involved. But when you look at the rock, that's not what you see. You see the opposite. Here in the textbook, Principles of Stratigraphy, I was taught from at 2 different state universities. To some thoughtful stratigraphers, this amazing discovery, that is the billions of years that they are now claiming, is just what the rock experts thought. No. It presented a dilemma because studying the rocks looks different. If the known stratified rocks have been accumulating throughout this vast span of time, the average rate of deposition must have been extremely slow. Yet there is very good evidence that individual beds accumulated rapidly. Did you know about that? The ones that study the rocks know these great ages are a dilemma when you're looking at the rocks, because there is very good evidence they accumulated rapidly. Now, what's he talking about? Well, for example, you look at this, which you think is a shrimp? No, it's a rock, but it looks like a shrimp. Now, how long did it take that rock to form? You ladies know you can put the shrimp in the refrigerator and it'll just last for years and years and years. Right? No. What happens when the shrimp dies and lays out on the beach? How long is he going to look like this? And these are not unusual, but that's exactly what they're talking about when they talk about the very good evidence that it happened rapidly. These shrimp were perfectly preserved over hundreds of thousands of years. You think? I mean, just think about it. How long did it take the rock to form? It formed before this could decay. When you look at shrimp like this, how long are they going to stay like that? Well, the rock had to form while it was still like that. In fact, it's gotten even worse as we're doing more collecting. This is a recent discovery, 2015, not only of the shrimp, but of the shrimp's brains. Natural History Museum of London have 7 new fossils. And what was undoubtedly a brain, it looked something like a simple shrimp, a brain a lot like modern crustaceans. So we got shrimp and we got shrimp brains that are preserved before it had time to deteriorate in the rock. And then we have fossils that look like this. In the process of eating their supper, how long did it take those rocks to form? Just think about it. Won't hurt. I enjoy eating with my brethren from time to time, and some of them, are kind of pokey, and it's a little aggravating maybe, but it doesn't take hundreds of thousands of years, does it? These fish, and this is not an unusual phenomenon that you see in the rock. I found an extra the other day, and I just put that one on top. We've got a number of them in our museum back here. They're called aspirations, and it's not, well, now, just try to imagine that happening slowly. At the rate of 2 centimeters in 1,000 years, 30,000 years a foot, come on now. What's going to happen to the top of that fish? He's caught in eating the meal. And then you look at examples like this, looking like a tree in the rock, but it's actually a fern, large lepidodendron, up above Knoxville, Tennessee, in the Cumberland Mountains, the bottom of it sticking through a coal seam, and the top of it through another coal seam, with hundreds of layers in between, and it's as well preserved at the top as it is at the bottom. Now, how long does it take a fern to wilt? Doesn't take long, does it? Why isn't the top of that eroded away if it's taking hundreds of thousands of years? We're looking here at that site, and I'm sitting there in the coal seam. That's over 12 feet from one coal seam to the other with hundreds of layers in between. You back up and you can actually see there are several of them here that have been exposed by this excavation process getting down to the coal. Now, how long did it take that to happen? And if it took a long time, why is it as well preserved top as much as at the top as at the bottom? How much time's involved? According to Schuchert, it would take 32,000 years to do 12 feet. In 6 months, if you're covering the bottom, that thing is going to be in trouble at the top. In a year, you can see a big difference. According to Officer and Drake, it'd take 360,000 years to cover this one fern. Now, that's just not possible. It's not going to work. I think there's a better explanation. I believe this is one catastrophic event, and I think I understand what that kind of event would be. What would it take to bury tall trees, ferns like this, and do it catastrophically? I think we understand that. It also tells us something about coal. In the coal seams, we see fossils that look like this. Of course, that fern was sticking down into the two coal seams. And again, how long does it take a fern to wilt? You ladies know something about that. It doesn't take long, does it? They get under the wrong conditions. Just in hours, you can see a significant difference. Here you see one bent over, not in position of growth, but bent and then like the one in the rock. But that rock formed before it could spring back. And it doesn't take long for it to look like this, but the rock formed, the coal formed before it could. Notice the description here from Science Daily, or 2014. The preservation happened so quickly that some of the cells have been preserved during the different stages of cell division. They found cell nuclei, cell membranes, even individual chromosomes. That happened, well, it got caught in something like concrete and preserved immediately. And then we'll add one more point from the same article. The royal ferns look essentially the same as they did during the Jurassic period. That's not tonight's subject, but we'll throw that in extra. Not much evolution going on. This is the case with with coal, and we find similar circumstances with oil. It doesn't take millions of years. In the lab, we can produce coal in about 6 hours. Oil takes anywhere from 20 minutes to a couple of hours. Here, U.S. Department of Energy is reporting here in 2013, algae into crude takes minutes in the lab. Reported recently in the Journal of Algal Research, out comes crude oil less than an hour. And of course, you've all heard that it doesn't take that long to produce oil, right? Now you hear millions and millions. Did anybody ever see it formed in millions of years? No. We've seen it form in less than an hour. That's what science is supposed to be about. We're duplicating the process in the earth that converted algae into oil over the course of millions of years. We're just doing it much faster. But the millions of years they didn't see. This, they're seeing. Coal, oil, ferns, not a long time to form. We look at large fossils like this ichthyosaur, which is a large reptile. We'll talk more about it later. This one's 28 feet, which is kind of a small one. We've uncovered one reported last month, 85 feet long in England. But 28, now, this is a big critter. Now, what's going to happen to the bottom of that fin? Over hundreds of thousands of years, he's finally getting covered up. Now, that had to be happening quickly. Looking closely, we see not only the bones preserved, but the adipose tissue in the upper portion there. And then looking even more closely at mommy ichthyosaur, we see the embryo preserved. And several of these in the Solnhofen limestone there in Bavaria, where these, many of them were found, they were obviously not happy about being covered up, like being caught in the concrete so quickly, and it triggered premature birth in many of them, and we can see the baby emerging from the birth canal, frozen in the limestone. Now, I can sympathize with some of these ladies that it seems like it takes millions of years to get that done. But it really doesn't take quite that long, does it? Seeing this frozen in the limestone is what Dunbar and Rogers were talking about. There's very good evidence that it takes place rapidly. This report was in PLOS 2014, showing the picture of the baby ichthyosaur emerging from the pelvis. Capture the moment. Y'all do that, don't you? The baby born Kodak moment. Capture the, in the limestone, baby emerging from the pelvis. And then try to sell the idea that this picture took place over millions of years or hundreds of thousands of years, 30,000 years afoot. That's just utter nonsense. It's very good evidence. He's not just making that up. There is good evidence. Octopus has no hard parts, or very few. How do you fossilize an octopus? Well, you do it quickly. He dies, lays out on the beach. He's not going to last very long. Preservation of an octopus as a fossil, complete with ink. Now, that's even more difficult. But the ink sac was preserved. Complete with suckers is about as unlikely as finding a fossil sneeze. If you're trying to say it took several thousand years to cover this up, yeah, I understand his problem. If it happens quickly, then, well, that's what's obviously indicated. We'll throw in one more point, again, not on the subject tonight. These things are 95 million years old, yet one of the fossils almost indistinguishable from living species. Yeah, we'll just get ahead of ourselves for Thursday night. We look at critters like the jellyfish floating around, gorgeous. Lecturing on this at a junior high not too long ago, and asked, now what are jellyfish made of? I was thinking maybe jelly or something. One little girl waved her hand. I know. They're made out of snot. Well, pretty close. But they're substantial enough to form fossils. And here are jellyfish in the rock with their mouth parts preserved. Now, the jellyfish dies, lays out on the beach, and stays there for thousands of years, you think? Hours, maybe? That's kind of stretching it. But beautiful fossils, and with the ripple marks, which of course move from minute to minute, all in the rock. Now, when Dunbar and Rogers say there is very good evidence the individual beds occurred rapidly, they know what they're talking about. That's accurate. All right, our time is up for this session, so let's see if some of you have some questions. A little bit over, maybe we'll catch up in the last half. Yes, sir.
So, what are the arguments against what you've presented, at least in my view, as pretty good evidence for a fast fossilization of these organic materials? I mean, what are the arguments when these arguments are made? What do proponents of a long or an old Earth say to that evidence?
That's part of the next session that we'll get to. Basically, they say, well, yes, the layers happen quickly, but the time is in between the layers. Science is supposed to be about what you see, no, but this we don't see in between the layers. That's where you. That sounds like I'm misrepresenting them, but we'll show you. That's exactly what they're saying. What else can they say? They know the time is there. They look at the fossils and they say rapid. They're in a tight spot. And many of them are acknowledging, I would say the majority would acknowledge, yes, the layers had to form rapidly. Though some of the ones that went to school 30 years ago would not, the ones who are up to date would know. And they don't try to contest that, but they put time in between, not in the layers, which we'll deal with. Yes, sir.
What's the whole carbon dating aspect? You mentioned the whole dating dinosaur bones and diamonds, and we have a much younger. There shouldn't be any carbon at all in
Right.
14, but it's there. So, what's their response to that? I bet that'd be a nail in the coffin.
These ignorant creationists don't know how to sample. Of course, we didn't even take the samples. Very few responses have been made. They get by with ignoring you if you're a creationist. That's part of it. They will try to say that sometimes, it's a background level, and we would expect a background level. Well, it's 100 times more than the background level, and they know that, which is really a dishonest response, but I've seen some try that. I don't think there is a good response. The RAPE project has been documented and published in the 2 big volumes, and make good doorsteps, big books, about 750 pages each. And if you want to get into the technical aspects of it, it's there. And then their responses to the few attempts that have been made are recorded there. Yes?
Follow-up question with the radioactive dating aspect. It seems to be that it's still widely used.
It's useful because they can get the answer they want by chucking 40 out of 41. And people say, wow, he dated it, and there it is. But they don't know the rest of the story, which Leakey's friend told on him in his book. I had a good friend who was running carbon lab up at Ball State University, and was visiting. He is, I say, he's a brother and he is a friend and is a gentleman, but we differ. And he was dating a peat bog and was explaining to me that he knew this was 20,000 years old, but all of the dates that he'd gotten thus far are 3 to 4, one was 5, which proved in his mind that this was contaminated, which likely was true. But he says, he dated 19, all of them coming out in just a very small amounts. So that in his mind was contamination. He says, we're going to get a good one yet. And he dumped all 19, and he's working on his 20th. He'll get the 20th, publish it, and see, we told you. That's the game that's played, and I don't think it's very scientific. Now, that's not the whole picture. When you're getting past 4,000 years, that's the kind of thing that consistently goes on. Less than 4,000 years, this side of the flood, it can be useful. You need to get 3 or 4 different dates and allow for contamination, but you can get an idea, usually. So there are places and times where it can be useful, and we will be dating the wood on the ark, predicting that it will be about 26 to 30,000. But certainly not 2 and not 30, or not 50. Yes.
You talked about the radiocarbon rate when you were talking about the closed system, and you said you could go into more depth on that as far as what evidence is there that those rates may have changed, and what are the conditions that might have created that?
That gets into a technical area, and let me back out of this, and I will do my best to respond to that. I got some pretty pictures. And this also, no, that's not going to work. Just a second here. We're getting close. There was an experiment that took place in White Sands, New Mexico, that involved drilling down through the granite almost a mile down and looking at the zircons that were in the granite a mile down. And the interest there was the fact that the zircon it's not a closed system, but it's closer than most. The lattice work of the crystal contains the material pretty well, and there is uranium that is decaying, and we find some uranium and some lead in these zircons, and so that's been measured, and that's coming out close to 1 million years worth of lead decay at the bottom. But the thing that's ignored by most of the experiments is that the decay process produces helium. Well, this is a closed system. This is part of their argument, but what they don't like to talk about is, well, it's not closed when it comes to the helium, because that escapes the lattice work. And it's a small molecule, and it's slippery, and we can understand that. But we can measure the escape velocity. We know under different temperatures, different circumstances, how much should escape. And if this is really old, it would all be gone quickly, because it doesn't take that long. Most of it's still there. What would be produced by this much decay is there in exactly what we would predict, which would all have been gone in just tens of thousands, well, less than 10,000 years. So what we've got is maybe 1 million years worth of decay in less than 10,000 years. Because if it were more than that, the helium would be gone. And we can demonstrate that by measuring the rates. The helium says it hasn't been that long. Let me illustrate. I'm over in Israel, and a Bedouin comes up to me and says, Dr. Patton, we have found an ancient tomb. And this is a great discovery. No telling what kind of treasures are in it. It's never been opened for at least 3,000 years, and you can be the first one. And so they bring me to the tomb, and here is this great discovery we're going to make. We creak open the doors, pry them open, and nobody's ever seen this for 3,000 years. Here's the treasures in the tomb. And then we look up on the ceiling and we say, wait a minute. I believe somebody's been in here not too long ago, which is the implication of finding the helium in the zircons. This says this has not been going on that long. We got helium balloons on the ceiling, which says decay went faster in the past. It went less than 10,000 years up to these, and we can demonstrate this in the laboratory, and there's a great deal in the rate books showing the conditions and the circumstances that will produce a variation in the rate. So I'd refer you to that. But this, just give you an illustration. This is one of the experiments that we've done. And everybody understands all of that, right? Hope we haven't glazed over everyone's eyes. I think our time is up. Let's take a break, about 5 minutes, and then we'll come back and show you some, I think, very exciting material. It gets better. All right. this is where we ended, particularly talking about the preserved soft tissue that would have to be preserved quickly, and many times you'll find them letting their guard down and acknowledging the problem. Here in this article from Phys.org, they're talking about the Burgess Shell, where you find lots of soft tissue preserved in exquisite detail. And the question of how this came to be has troubled scientists since the discovery of the fossils in 1909. They've known about this for a long time, and it's been troubling, and they don't have answers for that. It troubles scientists, and we've just getting more and more examples. But if you think that's trouble, what about preserved soft tissue that is still soft? In the million-year-old rock, so-called. For example, this is the slice of T-Rex bone, and these are blood cells that are still squishy in the T-Rex bone, which is not going to happen over millions of years, obviously. This was published back in '93 by Mary Schweitzer. She got lots of flack, people claiming all kinds of fraud, but she got it published, and here in Discover magazine, she is telling about some of the peer review process trying to get this published. Had one reviewer tell me he didn't care what the data said. He knew that what I was finding wasn't possible. And she's got this soft tissue from the bones that you squish and it stretch and it pulls back and snaps. And this, this is fresh stuff. He said it's not possible. I wrote back and said, well, what data would convince you? And he said, none. And I think he's right. We've run into this when we're trying to talk to people about the Bible. No, it doesn't matter what it says. I've had a number of discussions with Dr. Schweitzer, and she has acknowledged that, this is a quote from one of our correspondents, current theories do not account for soft tissue and cellular preservation. She cannot explain. Now, she's made some attempts, and she's published several things since then. The most recent, probably significant, involves actual dinosaur DNA. Now, this is really significant because this stuff doesn't hang around long. Our DNA gets damaged regularly, and our bodies have to repair it. And if we're not constantly repairing our DNA while we're alive, we're going to be in serious trouble. But over thousands of years, the material from outer space, radiation, penetrates and damages and is constantly being repaired. Well, here antibodies are being used now with bones to detect small particles, but they have detected with this very precise process, which did win a Nobel Prize, by the way, detecting DNA in dinosaurs that now has been published. Now, a lot of them are really aggravated about it, but there's no real good answer. How fast does DNA decay? Now, here Discover magazine just last year is giving the latest updated estimates, and for the past 20 years they've been talking about it, seeing it coming. Spielberg kind of warned them. You might find some dinosaur DNA. If you do, you got problems. It's ranged all the way from 10,000 up to millions. But here's the latest result. When organisms die, their DNA decomposes. Calculations predict that in optimal conditions, and this is the best circumstance possible, and they're talking about frozen. Now, the Hell Creek Formation, where these dinosaur bones came from, it's not frozen. It's a mega heated situation. In fact, the half-life of DNA has been measured there under those conditions, and it comes out to about 2,000 years for the half-life. You can measure about 5, so we're looking at 50,000 maximum, and we still got it. But under optimal conditions, very cold, DNA could survive for around 1 million years. But these dinosaurs are supposed to be 100 million years. And it can only survive 1 million, and we have DNA there. So we're talking thousands, not millions, for the dinosaurs, which is really upsetting a lot of apple carts. I think that's exciting evidence. But let's think about that in terms of geology in general and what we see on the earth. The T-Rex bones show their blood vessels, their blood cells that are still intact, the gushy stuff that stretches and snaps back, proteins that can be sequenced that would not last that long, even now DNA in the dinosaur bone. That all says that these fossils are not old. I think that's an obvious, justified conclusion. They can't be. Now, think about the implications of that. If the fossils in the layers are not old, what would that say about the layers? The layers couldn't be old, could they? And we look at scenes like this and they say, see, this is evidence for millions of years, but the fossils in the rocks are not old, and that says the layers couldn't be old. The question is, where's the time? And it's not in the layers, which they acknowledge now happen rapidly. The answer today is it's in between the layers. And most would acknowledge, yes, this happened rapidly, but this is where we're going to put the time. And I would, in my first response, say, well, you mean where there is no evidence? I'm going to stick with the evidence. You can go where there is no evidence. But it's worse than that, because there is evidence there, and it does not support the idea of time. But notice the thinking as expressed here by Derek Ager, who at the time this was written was president of the British Geological Association. We cannot escape the conclusion that sedimentation was at times very rapid. And in the context, he's talking about some of these ferns and trees that are standing upright through many layers, the Polystrate fossils. Yep, we got to admit that, yeah, it's rapid. Indeed, that at other times there were long breaks in the sedimentation. Now, why would you think that? Well, it's not because of what they see. It looks uniform and continuous, but he believes that there were breaks there because he has to believe the earth's old. That's just part of his philosophical makeup. It's not because of what he sees. What he sees looks uniform and continuous, and indeed it does. When you study the rocks, you know layers smooth and knife-edged like this between the layers will not allow time. Bioturbidation is a technical term that describes what happens when a layer is exposed at the surface for any length of time. Grass sends roots down, clams, burrow, animals, worms, and just plow that up. When you have a hurricane coming in the Gulf, it will leave a 3 or 4 foot layer that's recognizable. This is the hurricane layer. You come back 10 years later, it's gone because of bioturbidation. It's not. So you cannot have these straight, level, smooth lines exposed for hundreds of thousands of years. But he puts it this way: the geologic record is constantly lying to us. Now, we're supposed to follow the evidence, right? No, he's not going to follow here. It pretends to tell us the whole truth when it's only telling us a small part of it. May be paradoxical, but to me, the gaps probably cover most of Earth history. Well, you got no evidence, there's a gap. Well, scientists are taught it's the data that matters. It's not what you imagine where there's no data. But that's what he's saying. It was during the breaks that most events probably occurred. It's the gaps that really matter. Now, I think he's got it backwards, but he's shoehorning in his idea without the data. But we look at the breaks in between. Here's the Coconino Sandstone and the Hermit Shale down near the base of Grand Canyon. And the challenge for the evolutionist is there's about 110 million years that are missing here. And their explanation is, well, there was erosion here for 110 million years, but look at that surface. That doesn't look like an erosion surface, does it? nor does the rest of the canyon. We can follow the straight, smooth lines for 300 miles. When a surface is exposed for a period of time, it produces scenes like this. Erosion, we know what that looks like. That's not seen anywhere in the canyon. It's smooth and level all the way. And we look between these layers at the contact lines, and we see little bird tracks, and we see ripple marks everywhere. All layers falling far enough, you got ripple marks. Animal tracks, raindrop impressions. At Glen Rose that we'll be looking at Wednesday evening, here's the dinosaur tracks and the ripple marks around them. In order for that to be preserved, it's like what you see out here in the concrete. Some of the kids run around here and stick their feet in. How do you do that? Well, you've got to have that preserved quickly, rapidly, in order to preserve the tracks, or the next rain washes it away. And then erosion will erode it quickly within tens of years, and so the next layer has to come on top of it in order to preserve it. And it has a top with ripple marks on it that has to be preserved, formed quickly, and then another layer on top of it to preserve. So it's one after the other that has to be rapid. All of the layers have ripple marks, which says it was all rapid and all sequential, one after the other. Now, there's another spot where that becomes really dramatically obvious. The red wall is maybe the most dramatic layer in the canyon that people see from a distance. The Mississippian, and that's almost halfway up the geologic column. Directly under it is the Muav Cambrian. That's the lowest layer in the geologic column. In between is at least 150 to 200 million years that's missing. Well, okay, you can have that if you got erosion for 150 million years. It doesn't look like that, but okay, in spite of the fact the way it looks, there had to be erosion there, except you look closely here and you see the Muav, you go to the red wall, and then you go back to the Muav. Now, wait a minute, how do you go back 150 million years after you went forward 150 million years? You do that 8 times, back and forth and back and forth. How do you skip 150 million years 8 times? That's nonsense. They're interbedded, which says they are contemporaneous, and that's in all the stratigraphy textbooks. You've got interbedded layers, they're contemporaneous. We understand that. And if they are, then this picture in the geologic column can't possibly be true. It looks uniform and continuous, and it is. And we can demonstrate that. The layers are contemporaneous. They cannot possibly be millions of years apart. Well, then that raises another question. How do we get that many layers, this picture like this, forming rapidly? And I think the answer is it happens catastrophically, and that's the only way you can get a picture like this. We saw that happen with Mount St. Helens when in 1980 it blew its top and blew a catastrophic cloud, a pyroclastic cloud across the countryside, dumping debris from the mountainside all across the countryside, damming up Spirit Lake, and then Spirit Lake's dam broke and eroded down through the newly laid sediment and revealed about 600 feet of sediment that had laid down in perfect layers formed at 150 miles an hour rapidly. And of course that little trickle down the middle is what carved that whole canyon. No, I don't think so. That's what's left with the great flood that came through. But here we're looking at layers that formed at 150 miles an hour on May the 18th. Now, some of it a few weeks later, but almost all of it one afternoon. Finely layered, laminated rock, and you hit it with a hammer now, it rings like a bell. This is exactly what it looks like on the side of Grand Canyon that we know, we saw, formed rapidly. Now, we didn't see Grand Canyon form, but we saw this. It looks exactly the same, and we know it was rapid, and we can see the canyon that resulted, not carved by that little bitty trickle, but what's left from what carved that little bitty trickle, which looks just like the landforms, the morphology of Grand Canyon. Does it look like Grand Canyon? I think it looks very, well, actually that is Grand Canyon. This is Mount St. Helens, which reminds me of the cartoon a friend of mine drew here. This million-year-old canyon was formed by Mount St. Helens in 1980. But it's a demonstration of where the layers came. They had to form rapidly, one after the other, and we see it happening. We go to some caves, and they often will tell us this takes hundreds of thousands of years. My textbook said 1 inch in 100,000 years, and that's propaganda that influences a lot of people. Some of you may recognize Mark Mayberry there from a long time ago in one of the caves. Don't have time to tell the whole story, but the limestone from this building, George Rogers Clark Memorial, came from about 4 miles from the cave we just looked at. This is the Bedford limestone, the same limestone that was on the Empire State Building. And water percolates down through the cracks in this building just like it does in the caves. And in the basement, you have the same kind of formations that you have in the caves. Actually, a member of the National Theological Society had told me about this. And he had had his camera taken away. We actually had a conflict resolved with the legislature, which demanded that I be allowed in. They were trying to keep me out. But we got in, and here's 5 columns together with the speleotherms hanging from the ceiling. And now then that lid has been blown off, and they've begun to acknowledge this. Here from the Evansville Courier Press, stalactites have been growing in the basement of George Rogers Clark Memorial in Vincennes, Indiana, because of leaks since it opened in 1933. So in less than 40 years, big formations were forming. Carlsbad Caverns, of course, really, really huge formations, may have taken 1,000 years. We noticed bats, of course, flying around all over the place. They're pretty swift. This one either was really, really slow, or the stalactite was really, really fast. But here's a bat trapped in a stalactite. Now, how long did it take that stalactite to form? Just think about it. Out in West Texas, near Ira Ann, I found this cowboy boot, which is not petrified, but inside it has a petrified cowboy leg with part of the flesh preserved. He had an unfortunate accident, but we can see actually some of the festered part of the wound preserved in the fossil. We carried this to the hospital, not that we could help him any, but his foot was all broken. We wanted to see what the bones were like down in the boot, and they needed a name to put on the CAT scan. It came back Unfortunate Cowboy. We prefer to call him the Limestone Cowboy. But he's petrified and preserved in a boot that was made by the Geologic Boot Company in the early 50s. So it doesn't take that long to petrify things. When you look at the geologic formations, you see everything is rapid. The detailed polystrate fossil of the shrimp, jellyfish, ferns, trees, soft tissue, the sequential layers requiring one after the other, polystrate trees, the ferns, the coal, the oil, the petrification processes, these do not take a long time. That's propaganda. It's not so. And when you understand geologic phenomena and actually argue for a young Earth, because they're all rapid, Now, why do you think the Earth's old? It's not because of radiometric dating. That's not a real good scientific answer. And it's not because of the geologic phenomenon either. There are good reasons for a young Earth, and we'll quickly run through that. Killing two birds with one stone, I focused on two major arguments for the old Earth, showing they're really indicating a young Earth. But let's look at some of the young Earth evidence as acknowledged by Stanfield again, the anti-creationist who is fighting the idea, but at the same time honestly acknowledging, yep, there is some evidence for the young Earth, like water from volcanoes and lava from volcanoes, which he has given as an example and then provided some documentation. Now, you have to know a little bit about volcanoes. We've got about 600 of them that are active in the world today and about 10,000 that are inactive. I think that was from the flood, designed to destroy the world that then was. Now, in order to make estimates, we've got to have an average volcano, and Paracatin is down in Mexico is the one that is almost always used as an illustration of what's average. We saw it develop from nothing and measured all of the gas that's coming out. Almost all of it is H2O, and then measured the amount of lava, and this is the average standard in geology. Well, if we had 600 or 10,000, what would we see on the Earth's surface? 70 volcanoes, not 600 like we have today. 70 would provide all of the water in the ocean in 1 billion years, not 4.5 billion, but 1 billion years. 70 would fill the oceans. Nobody thinks it all came from volcanoes. 600 would fill the oceans 8 times. Wait a minute, that's kind of a problem for an old ager, isn't it? 4 volcanoes like this would provide for the entire crust of the Earth in 1 billion years. And we've got 600. 600 would do it 150 times, and a very small portion of the crust is lava. That's why he says, yeah, that says young, not old. We know about the Deepwater Horizon, the catastrophe down in the Gulf near New Orleans, and drilled into a pressure reservoir that just blew way up into the sky, indicating there's tremendous pressures down there. Well, now, how long can these pressures be maintained? You study petroleum geology, you study the porosity of the rock, and you can rather simply, with the porosity, understand how long it would maintain these pressures. And it comes out just a few tens of thousands of years, and boy, that pressure is still there. And that says young, not old. Uranium accumulation is very obvious. You can measure that precisely with the Geiger counters, and it is accumulating at about 50 times the rate that they would predict, right in line with ours. The radiocarbon in the atmosphere, Libby, who got the Nobel Prize for it, says it would be in equilibrium at no more than 30,000 years. It's not there yet. It's about 20% short, slows down as it approaches. That says it's less than 30,000 years old, just by their standard. Helium in the atmosphere, similarly, about 1/50th the amount. That's produced from radioactive decay, which is supposed to have been going on 4.5 billion years, 1 half-life. 8 times as much helium would be produced. No, not there. Meteoric dust in the strata, Stanfield says there's virtually none. Patterson has measured 14.5 million tons per year coming down through the atmosphere, and about 20% of it is nickel. Well, there's almost no nickel in the Earth's crust. There'd be a layer of nickel 50 feet thick at the rate that he's talking about. No, it's not there. Meteorites in the strata, if this happened over 500 million years, what we're seeing in the geologic column, then we ought to have all kind of meteorites preserved. We can't find any, he says. I think we found 1 or 2, which would be expected perhaps in the year of the flood. But a year, yep, that fits. 500 million years, that doesn't fit at all. And maybe the most dramatic, one of the very obvious indications of a young Earth involves population dynamics. We've heard of the population bomb and talked a little bit, well, we'll talk more about that Friday evening. You have to know the growth rate. In the US, it's very slow relative to the rest of the world, less than 1%, 0.81%. So let's slow the rate down for our calculations to be as conservative as we can, and obviously we're kind of playing with the numbers here. Let's begin with 8 people, go for 4,500 years, which is the time from the flood to today, at 0.46 growth rate, which is about half of what we actually have in the U.S., and what the U.S. has is much less than the rest of the world. About 7 billion people is what you come up with, and that's about what we're looking at. That's right on. Well, let's try it from the evolutionist perspective, doing the same thing with 2 people and a growth rate of 0.46, same growth rate, 200,000 years. That's nothing. That's a drop in the bucket for the evolution. But just to illustrate the point, you come up with 10 to the 398th, which, if you know anything about scientific notation, that's absurd. Absolutely. If you get 10 to the 18th, you're wrong. 10 to the 65th electrons in the galaxy. But they're talking about 10 to the 398th. Move from the galaxy to the universe, you just go to 10 to the 80th, from 65 to 80. But 10 to the 380th, that's absurd. This one is right on, and the evolutionist is just off the wall. It won't work if you go 200,000 years at the rate that we're, at half the rate that we're seeing right now. That says young. And so we've got lots of evidence, even according to the anti-creationist, that clearly indicate a young age of the Earth, and that's pretty weighty evidence. On the other hand, I think most of the geologic evidence and the even radiometric dating belongs on the other side. But those are not very good evidences, and there are not many of them. We've got more and better, and they've got fewer and not so good. And I think that's a pretty fair representation of the scientific evidence. And therefore, I conclude scientifically that the Earth is young, not based necessarily on what Genesis says. I think that's good evidence, and from Genesis we see the same kind of indication. But the best scientific evidence is that it's thousands, not billions. That doesn't work, but thousands does. Now, quickly, and then we'll have a few minutes for questions, just about the implications. If the Earth's billions of years old, how much do you worry about it ending next Thursday? It just puts a whole different flavor on the imminent end, the threat, the reality. If it's been here for billions and billions of years, however, if it wasn't that long ago, just a short period of time, and the book that says it happened a short period of time is true and says it's going to end, and it may be today, and that's what it says, then the world looks different, and that becomes real. But the dull edge of accountability disappears if you've just got billions of years to comfort yourself with. It escapes that sharp edge of accountability. It has an impact. All right, let's see if some of you have some questions. Yes, sir.
Of the young Earth creationists, what is the range for the age of Earth that they typically give?
You mean in these dating methods?
No, the young Earth creationists.
And what they would think, at least in what they think the age is. Most of them, I would suspect, would go with the Masoretic, which I think is a mistake. I think we have really good evidence. Much of it just came to light in the past 6 months. that really substantiates the Septuagint version, which would give a little bit more than the Masoretic, which is not going to affect the picture of evolution, but we're looking at just over 7,000 years, as opposed to just over 6,000 years with the Masoretic. There's good evidence that the Masoretes in the 600s, with a view to escaping the implications of Daniel's chronology, pointing out the Messiah fits, changed the dates in the Masoretic by hundreds and fifties. And we can know when that happened and where and why. And there's been some really good material published on that, documenting that. So Jesus, of course, quoted from the Septuagint most of the time, and it's not a bad recommendation. So I think we're looking, if you go by the Septuagint, you're talking about 333. And I think that's implied. I think you have a complete chronology, even apart from a complete genealogy, which is a point that is lost on many. You see some variations, and 14, 14, and 14 would indicate some flexibility that we see when we see the chronologies in Luke. But the derived, the original chronologies, not the derived ones, are the ones that are more dependable. And you find the age of the father given at the time that the next one in line was born, even if that next one in line was the grandson or great-grandson. If this one was 205 years old when that one was born, doesn't matter whether he's 2 or 3 generations removed. And then you know how old this one was when the next one is born. Maybe you skip a few, but you've got a complete chronology. And why would the Holy Spirit tell us how old the father was when the next one in line was born, all the way to Joseph from Adam? Sometimes people look at my situation. I've got a son that's about 28 years old, and they look at me and they say, "How old were you when that son was born?" And you know what I tell them? It's none of your business. I don't mind telling them, but it really is irrelevant unless you're trying to be nosy and figure out some things, which is what God gave us the ability to do with that information, a complete chronology all the way down to Joseph, and from that point we're into historical times and can get very close. Maybe I've answered your question. What most of them think, most of them would still go with the Masoretic at this point. But if you're looking at science, they would say, well, you can't draw a fine line, and thousands as opposed to billions would be probably the finest line you could draw. Yes?
When did the idea of billions of years really catch on?
It's been around for forever, since the devil, a long time ago. You see it before the ancient Greeks. They were talking, maybe not, that is implied in some of their writings and before. But then, of course, there are those that opposed it then, and same kind of conflicts that you can see. In modern times, Lyell was probably more responsible than any other and influenced Darwin and really provided the foundation for Darwin to write his book. Without Lyell's work, assuming that everything that we see today is at a constant rate, that the present is the key to the past, he would look at some things that we know happen quickly, like down at Tierra del Fuego, canyons that we can prove happen quickly. He assumed, based on present rates, it took millions of years. Well, no, we know historically when it happened. That's been reviewed. But that unwarranted assumption formed the foundation of his thinking. And that's where the modern view took root and blossomed. Other questions? All right, our time is up. We thank you very much for your attention. Tomorrow night, we're talking about the record of the rocks. Probably my favorite night. We get to talk about some things we've done around the world, dinosaurs and dinosaur footprints. We hope that you can be here then.